Hi guys, welcome to another Learn Electronics Repair video. In this video we're going to take a look at Zener Diodes. So this is all you need to know about Zener Diodes to fix stuff. And while we're at it, we'll also have a quick look at TVS Diodes, which are a very similar device. So Zener Diode, what is it? Well, first of all, it's a diode, so it's a semiconductor. Obviously it's a diode, and a diode passes current in one direction from anode to cathode. I know cathode usually with a K for some reason, even though it's spelled with a C. And current passes in this direction, but it doesn't pass in the reverse direction. I made a whole video, all you need to know about diodes to fix stuff, so I'll link that from this one and you can watch it. So here we have our diode passing current in one direction. What happens when we try to pass current the other way? Well, it blocks it to an extent. If you continually increase the voltage in the reverse direction, it will reach a point at which it breaks down. It can no longer withstand the voltage and it breaks down in the reverse direction. And I can show you this quite easily on the graph, not to scale. So in the forward direction, that's this direction, this is volts and this is current. So in the forward direction, it doesn't actually conduct until you reach a certain voltage, which is generally for a silicon diode about 0.6 of a volt. So when the voltage is below 0.6, it doesn't actually conduct. Okay, so it's 0. And at 0.6 of a volt, it suddenly conducts. And after that, the current goes up rapidly to the point where the diode cannot pass any more current. You would destroy it if it was running into a short circuit or there wasn't some way to limit the current. So that's what actually happens in the forward direction. In the reverse direction, as we know, it doesn't conduct, but eventually you will reach a point at which it does conduct, and the same thing happens. It suddenly conducts and conducts more and more current rapidly. So again, if there was nothing to limit the current, you would destroy the device. So for a rectifier diode, this is typically like 50 volts, 100 volts, 200 volts, 1000 volts, and various ones in between. So for a normal rectifier diode, we choose a value that's suitable for the application so that this never happens. But with a Zener diode, we actually rely on this. So with your Zener diode, the symbol is this, and sometimes it's drawn like this. And we have a similar situation. Current, I'll put the symbol IV for volts. So in the forward direction, it behaves like a diode. It's a diode. So when it reaches about 0.6 of a volt, it conducts. Yeah, it's just a diode. But the clever thing with the Zener diode is that it can be made so that this breakdown voltage is at a specific set voltage. So you could, for instance, have a 12 volt Zener that will break down at 12 volts. Okay, or we could have an 18 volt Zener. And they come in a whole variety of values. The lowest ones were about 2 volts. The highest ones I find normally, let me see what I have, I'll tell you. The highest ones I have are 130 volts, but it may go higher than that. But typically, for most circuits, the Zener diodes are like 30 volts or less. So, with the Zener diode in the circuit, it's actually this that we're using it for, the fact it will break down at a certain voltage. So, whereas with a normal diode, rectifier, you will have a positive supply passing through the diode into a load, something like this, or AC most likely coming in, so it only passes the positive half cycles, and here you get the positive halves. Yeah, with a Zener diode, it's working the opposite way, as I said. So with a Zener diode, you'll have a circuit like this. You have a positive supply, The Zener diode is connected back to front. Okay. It will have a resistor to limit the current. We'll put the resistor in here. And typically it will go to ground. And at this point here now is a voltage that is regulated by the diode. So if this is, for example, is a 12 volt Zener, the voltage here will always be 12 volts if you measure it. This can be your load to ground. So no matter what the input voltage is, within reason, there will always be 12 volts here, and that's what a Zener diode does. If we look at some Zener diodes, and these are through-hole Zener diodes, you can see they have markings on them mainly. This one's 3.9 volts, these are 4.7 volts, 5.6 volts, and so on. This one, actually, you know, it isn't marked, and we'll figure out what this one is in a minute. Oh, 3.3 volts, 3V3. So those are typical Zener diodes. These are going from 3.3 to 30 volts. The main ratings for a Zener diode are the voltage, the Zener voltage, the voltage at which it breaks down and regulates, and the wattage. So these are 1 watt Zener diodes. That's quite typical. You'll find 400 milliwatt ones, and you can find high-powered 5 watt and more Zener diodes. But you tend to find those in older equipment. You don't really tend to see that very commonly these days, and that's because a Zener diode is quite an inefficient way of regulating the voltage, and for higher powered uses there are far more efficient methods in use these days. Surface mount ones typically look the same as this, but just have metal caps at the end, like between my thumbnails here. So it's just soldered straight down to the board, couple metal caps on, and there's no leads. I don't have any to hand, but a surface mount Zener diode looks basically like this. You can see, looking at a Zener diode, they look much like a rectifier diode. You normally can't tell whether a Zener is a Zener or whether it's just a diode by looking at a device. It may have a part number on, at one end something maybe, or it might be marked with a voltage. You can often tell if a diode is a Zener diode in two ways. One is the position in circuit. If effectively the cathode, the stripe is towards the positive, it's most likely a Zener diode. And the second one is the marking on the screen printed on the circuit board. Often you'll find a Zener diode on the schematic or on the silk screen printing on the PCB marked as ZD. So ZD1, ZD100, ZD8 and so on. So that's a good indication that it's actually a Zener diode. Zener diodes are used in two main ways really. One is this sort of circuit where effectively it's a voltage reference, where it sets a certain voltage which will always be the same regardless of the supply voltage. This can also be used to make a simple voltage regulator as well. I can show you this. So you have a circuit like this with a transistor. This is an NPN transistor, and from the base we have a Zener diode going to ground. From here we have a resistor. This is in and this is out. And the voltage on out, the output voltage, will basically be set by the diode. A transistor like this is called an emitter follower. So basically the emitter follows the voltage on the base, but it's 0.6 of a volt less because there's a voltage drop across the junction. So for instance, if here was like a 12 volt Zener, coming out of this here would be about 11.4 volts. And that will be fixed regardless of what the input voltage is. As long as the input is more than 12, that will be fixed. And we use it like this because the transistor can dissipate a lot more wattage than just the Zener. So this can give you a high current stabilized supply. So that's one of the main purposes. The other main purpose you'll find them is where you have something like this. So you have a secondary winding of a transformer, maybe a switch mode transformer. This has a supply with a rectifier diode. This is a normal rectifier diode, capacitor, here, and this is going to some sort of load, maybe an IC. You will find then often from here to here a Zener diode like so. And this Zener diode isn't meant to conduct, it's meant as a protection device. So say this is a 12 volt supply and the chip requires 12 volt, the chip connected to here. This might be set to be using a 15 volt Zener. So in normal situations there's 12 volts across it, there's never more than 12 volts across it, so it doesn't actually do anything normally. It only does something if, due to some fault condition, the voltage here goes above 15, in which case this will clamp it to 15, it will stop it going any more than 15. If a lot of current is flowing, this will probably go short and just short it out as a protection device, so you see that. Which brings me on to how do Zener diodes fail? Well, they fail basically in two ways. They go short or they go open. They don't really fail in such a way like the Zener voltage changes. I'm not saying never, but I'm saying that that isn't a typical way for a Zener diode to fail. If it's going to fail, it'll go short circuit or it'll go open circuit. So this brings us now to the question, can we test a Zener diode without a multimeter? Well, the basic answer to that is yes, because Zener diodes only tend to fail in the way I've just mentioned. They go short or they go open. So if I take the 24 volt Zener diode, I have plenty of them here, and I take the multimeter, and we go on to diode mode, and we check our diode, Zener diode, you will find that in one direction it conducts and the other one it doesn't. So this way it's open circuit, and if we go the other way it conducts. Okay, it's 0.7 rather than 0.6, but it's typical to what you would find for a rectifier diode. Let's just go for another one. So this is actually 18 volt Zener. In one direction it conducts 3.7, and the other direction it's open. So to your multimeter, a Zener diode will look just like a diode, and because they tend to fail in one of these two ways, pretty much so, yes, you can test the Zener diode in circuit quite often, and certainly out of circuit like that. But we can't measure a Zener diode with the multimeter if we don't know what the value is, or for some reason we do want to measure the Zener voltage, we have to do it a different way. The basic method for testing a Zener diode is to take a power supply that has a voltage higher than the Zener you want to test. Most bench power supplies will go to 30 volts and some will go to 60 volts, and that'll probably cover you for pretty much every Zener diode you ever want to test. So we take our bench PSU, our 30 volt supply, plus and minus, and we connect the plus via a resistor to the diode we want to test. So this is where we want to test the diode. We connect it this way round with the cathode towards a positive, back to front for a normal diode, and we connect it like so. And we can take our voltmeter and we can measure from here to here, and whatever voltage we measure is the Zener voltage. The resistor isn't particularly critical. Another good way to test Zener diodes, and actually to measure the voltage of the Zener diode, is to use the amazing short circuit finder that I showed you how to build a few weeks ago. You did build this, yeah? Because it's a very useful tool. So we have the voltage meter set to volts. This is set to 4.5 volts, which is how we were using as a short circuit finder. But to test Zeners, it needs to be set to higher than the highest voltage Zener we want to test. The highest my power supply is to 31.7, so we'll use that. So we can now take a Zener diode and we can test it. Now in one direction it will look just like a diode, so we'll just see the forward voltage drop. So there we have 8.47, yeah, 0.84 of a volt. And the other direction will read the Zener voltage, so we can just go across it. It's reading 4.4, so that's the Zener voltage. This is actually a 3.9. It reads a little bit higher than the rated amount. That's probably because this is putting 50 milliamps through. If you change this resistor for a higher value resistor, so this is a 22 ohms giving you 50 milliamps. So if you change this to around 100 ohms if you wish, that should give you about 10 milliamps, and that probably would read more accurately. But we can certainly see that the Zener diode is working, okay? Let's have a look at another one. So these are 18 volt Zeners. So once again, if we measure in the forward direction, it's just a diode. 0.87, yeah. Read the other way. It's reading 19, so we know the Zener's working. Let's just check this isn't going to actually damage anything. So I think the highest one we can test is going to be a 30, but it probably won't read this. We probably need the supply to be maybe 35 volts. It needs a little bit of headroom to actually give you a reading. But let's try it on a 30 volt Zener and see if this actually changes. Yeah, it does a little bit. Let's go again. I just need to get a good connection on it. One moment. I'm reading the forward direction, 0.9. Read it the other way, positive to the cathode. Yeah, and it drops a little bit. So it is actually reading it and testing that 30 volt Zener. Okay, we can see that. These are 1 watt Zeners. Let's just have a look at a couple of lower powered ones. These are, I think, 400 milliwatts, which are about the lowest powered ones I actually have. This is a 2 volt Zener, which is the lowest voltage one I have. So let's just see if these are okay to test with our 50 milliamp tester. So we'll go forward. And it's reading, yeah, 0.8. And I've lost it, just get it back. There we go. Now let's test it in the Zener direction, see if it reads 2 or thereabouts, and see if it's okay. Yeah, it's reading 2.8. I'll just keep it on there a little while. I don't think it's maybe slightly warm to the touch, but it certainly was quite happy with that. And we'll just try now one more. This is one of the small ones again. So 27 volt Zener. So again, we'll just measure it in the correct direction this time. The Zener voltage from here to here, 29. Okay, so we can test the Zeners with our little short circuit finder, which is now even slightly more amazing than it was before, yeah? Finally, I'll just mention about TVS, or Transient Voltage Suppression Diodes. The symbol looks like this. And basically, it's like a Zener diode, but in both directions, so it doesn't normally conduct in one direction. Effectively, it's kind of like having a normal diode, if you like, in series with a Zener diode, like so, but in both directions. So, if we took 2 Zener diodes like this, and we put this end positive, this would just conduct like a diode, and this would act like a Zener diode. So nothing would pass through in the way of current until we reach the Zener voltage, whatever it is. And the same in the other direction. If this end's positive, this conducts like a normal diode, but this is acting as a Zener. So again, no current will pass until we reach the Zener voltage. And these are used as a protection device. So it's TVS, Transient Voltage Suppression. Basically, with a TVS diode, it's designed not to be doing anything really, unless like there's a voltage spike, a transient voltage in which it conducts it away, it suppresses it, or an incorrect supply voltage is connected, in which case it usually just goes short circuit. So if you test them, generally they won't read in either direction, it's just open until effectively it's needed, and then it conducts and becomes effectively like a short. So that's what a TVS diode is, and because of the way they work, mostly you don't need to worry about them. If you find a faulty one, it's going to be short circuit, and you'll know there's a problem. I think then, from the point of view of repair, that's all you need to know about Zener diodes to fix stuff. Hope you enjoyed that short video. Hope you learnt something, and I will see you all soon on another Learn Electronics Repair video. Ciao for now, guys.